Assalamualaikum and hello everyone. We are from AS1205E and today we are going to present about gas chromatography. These are our group members, starting with Ahmad Farhan Hakim, Nur Fitri Batrisha, Inshira Fatihah, Siti Rauda, and me myself Anissa Sofia.
First of all, we need to know what gas chromatography actually is. Gas chromatography is a technique used to separate volatile compounds in a mixture. In this method, an inert gas such as helium or nitrogen acts as the mobile phase and carries the sample through a long chromatographic column. Inside the column, the components of the mixture interact differently with the stationary phase depending on their physical and chemical properties. Because of these different interactions, each compound travels through the column at a different rate, which causes the separation to occur. As each compound exits the column, it is detected and forms a distinct peak on the chromatogram. Each peak represents a different compound in the sample. The retention time, which is the time taken for a compound to travel from the injection point to the detector, can be used to identify the compound. Meanwhile, the size of the peak, measured by its height or area, indicates the amount of that compound present in the sample. Due to its high sensitivity, accuracy, and efficiency, gas chromatography is widely used for both qualitative and quantitative analysis. And these are our main objectives for this experiment. The first one is to determine the retention times of N-butanol and 2-propanol. The second one is to identify the components present in a standard mixture based on retention time. The third one is to identify the components present in an unknown sample. And the fourth one is to determine the effect of temperature on time retention and resolution. These are the apparatus used during the experiment. The first one is the syringe. The syringe was used to accurately measure and inject a small volume of the sample. The second one is a beaker, which was used to prepare and temporarily hold the solution during the experiment. And the last one is a dropper that used to transfer liquids drop by drop when only a small amount was required. Moving on to the chemicals, these are the chemicals used for this experiment. The first one is 2-propanol. The second one is N-butanol. The third one is standard mixture of 2-propanol and N-butanol, which is 1:1 ratio. And the last one, we use a random sample that we call as unknown sample.
Next, I will explain the methodology of gas chromatography experiment. First, the gas chromatography instrument was switched on and allowed to stabilize. Then, the carrier gas flow rate and oven temperature was set according to the experimental conditions. After that, the sample was drawn into the micro syringe and injected into the injector ports. Inside the injector, the sample was vaporized and carried by carrier gas into the column. As the sample passed through the column, separation of the compound occurred based on their volatility and interaction with the stationary phase. Finally, the separated compounds were detected by the detector and the signal was recorded by data system in the form of chromatogram. Gas chromatography consists of several important components. The carrier gas transports the vaporized sample through the columns. The injector introduces the sample into the system. The column separates the compound based on their properties and oven controls the column temperature. The detector detects each compound as it exits the columns, and the data system records the signal and displays the chromatogram. Column temperature plays an important role in gas chromatography. When the column temperature is increased, the retention time decreases and the compound elevates faster. However, this may result in poor peak resolution. In other hands, decrease the column temperature, increase the retention time and improve peak separation. But the analysis time becomes longer. That's all for me.
Now, let's take a look at the results. These were the data obtained from the gas chromatography graph. There are two compounds, which is propanol and butanol. For propanol, at the temperature of 70 degrees Celsius, the retention time is 5.783 minutes. Meanwhile, for propanol, at the same temperature, which is 70 degrees Celsius, the retention time is 6.911 minutes. And lastly, for the standard mixture, the retention time is both 5.78 and 6.895 minutes.
In this experiment, there will be a few questions. I will answer all of them. The first one is, volatile and non-polar compounds are suitable for GC because they can easily evaporate without decomposing, allowing them to be separated and detected efficiently. The second one is, FID has high sensitivity which allows it to detect very small amount of organic compound. It also produces a clear and stable signal with sharp, well-defined peak that can make the analysis more accurate. The third one is, the efficiency of GC column can be increased by using a longer column length, which provides more separation between compounds. In addition, using a small particle size can improve the interaction between the analyte and stationary phase, resulting in better resolution.
Hi, Assalamualaikum. My name is Fitri. So I will discuss about the discussion. For this experiment, we use gas chromatography to analyze alcohol compound. The column temperature was maintained at 70 degrees Celsius in this analysis. First, we will look at the pure compound, which is the retention time for propanol was 5.783 minutes, while butanol show a longer retention time, which is 6.911 minutes. Next, we analyze the standard mixture. Two clear and separated peaks were observed at 5.78 minutes and 6.895 minutes. These values are very close to the retention time of the pure compound, which showed that propanol and butanol were successfully separated and identified. The difference in the retention time between the two alcohols is mainly due to their molecular properties. Butanol has a longer carbon chain and higher molecular weight, so it interacts more strongly with the stationary phase and remain in the column longer. Contrast to the propanol has a shortened carbon chain and lower boiling point, which is cause it to have a less interaction with the stationary phase and elute early. The variation in retention time was very small, less than 0.02 minutes, indicating the gas chromatography method used in this experiment is reliable and reproducible. Any minor variation observed may be due to experimental factors such as a slight difference in injection in volume or the condition of the GC column.
So in conclusion, from this experiment, the retention time can be determined when the TR of N-butanol and 2-propanol is 6.895 and 5.78 minutes respectively. Besides, we can identify the component that is present in the mixture based on the retention time. We also learn the effect of temperature on the time retention and resolution. The higher the temperature, the higher the retention time. Hence, the resolution also increases.